Good afternoon, students. Today, the topic we're going to discuss is the perspective process model. And this is an approach in which we use four different types of software development models. That is waterfall model, prototype model, rapid application development model, and spiral model. So, first of all, what is this perspective process model is? Let's start with it. Perspective process model is a model that describes how to do according to certain software process system. How to do means if I have to develop a software, then how should I develop the software? What technique I should go for it? And what guidelines are being provided to me to design the software, to develop the software. So perspective model is a model that describe how to do according to certain software process system guidelines to organize and structure how software development activities should be performed. What activities, various activities have to be performed during the software development, and from which activity I have to start and to which activity I have to stop. All this activity has to be in particular order, and this is what the perspective model is. The guidelines to organize and structure how the software development activity should be performed and in what order. This is what the okay. The various models that come under the perspective model are waterfall model, prototype model, rapid application development model, and spiral model. So these are the four models. Today we go for only the waterfall model, and rest of model we do in the next coming lectures. So let's start with it. Let's have some brief introduction about the software. What software is? Software is set of instruction that one execute provide desired function and performance. Data structure that enable the program to adequately manipulate information and document that describe the operation and use of the program. So software, what is software? Software is set of instructions. Uh, when we execute, it gives some result by performing some activities, functions, and some data structure are being used in that set of instructions to manipulate the information. And every software has a document. With the help of document, we can understand what the software is doing. And what software engineering is? Software engineering is a dynamic approach to study, design, code, test, and maintain software as per the user requirement. So, okay, uh, this is what the waterfall model is. Various uh, phases are there in waterfall model. We start with the feasibility study, then we go for the requirement analysis, then design, coding, testing, and maintenance. So this is how we can go for the waterfall model. Why it is called waterfall model? Because it start from top and end at the bottom, just like a waterfall. You all have seen the waterfall in the mountains. Start from the top and end at the bottom. You can see the picture over here. There's a waterfall over here starting from top and ending at the bottom. That's why we call it waterfall model, because the very first step start from the top, that is feasibility study, and the last step is the maintenance at the end of it, and in between all the various operations or phases being performed to develop the software in waterfall model. So what the feasibility study is? Feasibility study is the system workability, user requirement, effective use of resources, and the cost effectiveness by means of economic, operational, business, technical, and social feasibility. So before developing a software, uh, whenever any software engineer got a job to develop a software, first of all, the software engineer will see that whether it is feasible to me to develop the software. Should I get some benefit of it for developing the software? Does I have all the software hardware requirements? Uh, does it affect my business? Do we have technically strong to develop the software? So first of all, if we check all these features, we call it as feasibility study. If the software engineer is having all that features within his organization, then he will go for yes. Unless he will say no, I cannot develop the software because I do not have such type of activities or infrastructure in my organization. So I'm not in a benefit to develop this software. I'm sorry, I cannot develop it if it is not feasible to the software engineer. If it is feasible to software engineer, then software engineer will move to the next step. The next step is the requirement analysis. The software engineer will ask the customer, okay, I am ready to develop the software. Tell me, what are your requirements? So the requirement analysis analyzes the needs of the end user or the customer and check the validity and possibility to implement user requirement. Whatever the requirement the user is discussing with the software engineer have to go one by one and will check it out whether the software engineer can go for all the requirements that are being asked by the customer or end user. After analysis, uh, the next phase is the software design. After discussing with the customer or end user, the software engineer team will sit together and design a pattern, what pattern we use to start the software development, and during what phases we have to go for, how many functions, how many modules we have to design, and which coding technique we have to use for it. So software design defines and describe the modules and their interfaces and interactions. The activity and behavior of software modules has to be documented. How many modules you have to prepare in our software development, how they will interact with each other, and they have to write proper documentation of it. As you can see in the picture, these all are the team of the software engineer that are deciding that how we can design the software. After designing, they will understand about the software, what we have to develop, how we have to develop. Then they start the coding of the software from designing to coding. As you have done in the last semester, that you have in data structures, you have done first algorithm, understanding the algorithm, then you go for the programming. Algorithm is what? This is designing of the software, and converting that algorithm to coding is the shifting from one phase to another phase. That is shifting from design to coding. Sorry. Okay, software coding transform the design of system into computer language format called write source code and internal documentation that verifies the specification of the document. So here the software engineer or his team start converting the software design into the coding by making one module at a time by each team member. After coding, testing is being done by the software engineering team, that whatever functions we have developed so far, are they working properly, are they interacting with each other properly, all the instructions that we have written in the software, are they working properly. So testing evaluates system whether it satisfies user requirement or not, identifying any gaps, error, or missing requirements in the contrary to the actual requirement by the alpha beta testing. So the software engineer will check that does the software is giving the output as per the requirement of the user that he has discussed in the requirement analysis. If all the requirements are being fulfilled, then it's very good. If anything is missing, again they will check where it is missing and make the improvement over there, debug the software, and make the software at that level that it will complete all the requirements of the user. And finally, the maintenance is the software maintenance modifies software products after delivery to the correct fault and improve the performance of the attributes. So uh, the the customer asks the software engineer that there are some few of the things I want to add to it or I want to delete from it. The software engineer say, okay, fine, I will add to it or I will delete from it. This addition or deletion is called the maintenance of the software as per the requirement of the uh, customer or end user. So this is all. This is a brief introduction about the waterfall model. Then we go for detail about the waterfall model. What the waterfall model is. So waterfall model is a simple model as the development phases are organized in linear order. In linear order means the first, then second, then third, then fourth, one by one by one. The design starts after the requirement analysis. So first we go to feasibility study, then requirement analysis, then go for design. It means design start after requirement analysis. The coding begin after design, and as per the diagram we can see over here, the coding begin after design, right? And the testing is done after the coding is completed. So you can only do testing when coding is completed, and after testing, the maintenance is done. When the testing is satisfied by the developer end, then the maintenance is done if required. The sequence of activities are: the first is feasibility study, then requirement analysis, the system design, then detailed design, then coding, then testing, and finally maintenance. These are all the activities that are being performed during the software development in waterfall model. So this is what the various activities or phases: feasibility study, requirement analysis, design, coding, testing, and maintenance. And now we go in one by one. All feasible. What is feasibility study? What is requirement analysis? What is design? So we start with the waterfall model again. That is all the phases of waterfall must be performed in any way for successful project. Any different ordering of the phases will result in less successful product. If you change the phases of the waterfall model before feasibility study, you go for the analysis, and before coding, you before design, you go for coding. It means you make some changes over there, you will get unsuccessful result over there. Fine. Verification means that verification is done at the software development end, and it means that it is the verification is a process that determines whether or not the product is given at the given phase of software development fulfill the specification or condition during the previous phase. That every phase is being verified, that it is giving the correct result. Then we move to the next phase. Validation means it is a process of evaluating software at the end of software development. At the end, we will check that whether software is valid or not. It is valid to give to the customer or not. So when the customer gets satisfied, we say that software is valid for the launch in the market. So this is what the diagram was of the waterfall model is: feasibility study, requirement analysis, design, coding, testing, and maintenance. Now let's start each activity one by one. So we start with the first one is the feasibility study. The feasibility study determines whether the proposed system can meet the user requirement effectively. If I am a software engineer, can I effectively develop the fulfill the requirement of the user? This will be done at in the feasibility study level or phase. The feasibility study is basically the test of the proposed system in the light of the workability, gathering user requirements, effective use of work source, and cost effectiveness. The feasibility is categorized as technical feasibility, operational feasibility, economics, schedule, and social feasibility. So before accepting any software, uh, you can say deal, I have to go for the feasibility study whether it is feasible for me or to my organization to develop the software. And to go for it, I have to go for the various activities like technical, operational, economic, social, etc. The main goal of the feasibility study is not to solve the problem but to achieve the possibility. So what is this feasibilities are? Economic feasibility is that the cost of solving the problem, which is generally demonstrated by cost benefit analysis. So in feasibility study, sorry, I go for uh, how much cost it will take to develop the software. Is it feasible for me to spend that much cost? Does my organization have that much money to develop the software? If it is yes, then I go for yes. Economic feasibility is positive to me. Then I go for operational feasibility, whether the problem can be solved in the user environment with existing and proposed system working. Does the current system that are running in the you can say market also have the same operations, or some additional operations are being added to it? If some additional operations are being added to it, then it's benefit for me to go for it. If it is already the same software that is already in the market, then there is no fun of me to making the, you can say, copy and paste of such a software. So if there are some few changes in that operations of the software that are existing in the market, then I go for to develop the software. Then organization feasibility, whether the proposed system is reliable to the organization strategy and objectives. So every organization, or you can say the organization that developed the software, has some particular rules and regulation objectives. Does that follow the objective or rule and regulations? If it does, then I will say that the organization feasibility is positive. Then I go for technical feasibility, whether the problem is solved using the existing technology and resources available in the organization. Whatever the resources my organization have, technical software or hardware, uh, can use by using that technical, you can say, measures, I can develop the software. So if I can, then I go for say yes positive for the technical feasibility. And last is social feasibility, whether the problem is solved without causing any social issues. The software that I'm going to develop is not harmful to the social or people of any age in the market. So if it is unharmful to the people of any age in the market, then I will ready to develop the software. Rest I will ignore to develop the software. So before starting the software, I have to go for the feasibility analysis of the software. So in the feasibility analysis, I go for economic, operational, organizational, technical, and social feasibility. So after the feasibility, economic, operational, organization, technical, and social, we move to the next step, that is the requirement analysis. In requirement analysis, define the software condition completely and should be documented with the customer before passing to the next phase. So in the requirement analysis, the requirement had to be collected by analyzing the needs of the end user or the customer by checking them for the validity or the possibility to implementation. The software engineer will interact with the customer or end user by one-to-one phase interaction and ask them what are your requirements, what you want from the software, what type of input you want, what type of output you want, how many modules you want, what type of operation you want, or it does if there's something is already in the market, what changes you want in that. So this is one-to-one interaction with the customer by the software engineer and ask the customer what are your requirement, and the software engineer will continuously writing a documentation of it to make it as a requirement analysis. The aim is to generate the requirement specification document, which is used as an input of the next phase of the module. So while interacting with the customer or end user, the software engineer will side by side or parallelly, you can say designing a documentation. We call that documentation as software requirement specification document, which will be helpful by moving on the next phase for the software development. After the one-to-one interaction with the customer and user, that is in the requirement analysis, the next phase is the design phase. So in the design phase, the internal logic of each of the modules specified in system detail is decided. So the team of the software engineer will sit together and they will discuss how they can solve the problem of the customer, all the requirements of all the requirements of the customer, and how many modules they have to develop, how the module will interact. So this can be done with the help of initial design and detailed design. In initial design, it is an architectural design which defines and describes the main module or components that interface and interact. That how many modules we have to design for software development, how they will work, and how they will interact to each other. By this, the software is split into its in components, and this involves definition or selection of computer platform and of operating system and peripheral hardware device, etc. So how many component or module we have to develop, under what platform we are going to design this, and how many various other hardware we have to require for development of software. So this is initial design. The software component have to be defined to meet the end user requirement and to meet the need of possible scalability. The aim of this phase is to generate the architecture document. So in every phase, document must be created. You can see we have generated the documentation in feasibility study. We have generated the document in requirement analysis. Similarly, we have to generate documentation in initial and detailed design also. So in detailed design is based on software block defined by software architecture design, and detailed design will break the design further down into code modules. So after this, we have to make the modules that how many modules we have to design on the coding, and the interface and interaction of the modules are described as well as the functional contents, that how many parameters are being passed by one module and how many parameters are being accepted by the other module. So the output of the phase is in the detailed design is documented, which is based on the following implementation of the work. So this is how the design will go for. After design, the next phase is the coding. While performing the coding, definitely you have to go for instructions, and whenever you write one instruction, you simultaneously check whether instruction is you can say correct or not. So parallelly you are doing the coding as well as unit testing. Unit testing means the instruction that you have written is correct or not. So what is the coding is? Coding phase is to translate the design of system into the code in the given programming language. So once you have designed the you can say requirement of the user as a software, using the algorithm or flowchart or ER diagram or DFT, whatever pattern you have used. After understanding the requirements and making the design of it, you start coding of the software. And in the coding, you because the software is set of instructions, definitely coding starts from instructions. First, you write an instruction, you check if the instruction is true or not. So if it is true, then you go to next instruction. It means you are testing simultaneously each and every instructions. So while writing the coding, we are also doing the unit testing also. The system is first developed in small portion called units. System is developed in small portion called units. They are able to stand alone from a functional aspect and are integrated later on to form complete software package. So you can say that uh, whenever we have to design a huge product, we have to always design from the sub products, or you can say mini products. So mini product make sub product make huge product. Similarly, to develop a software, we have to design first small units of it and then integrating all the units to make a proper software. So system is first developed in small portion called units. These are able to stand alone from a functional aspect and are integrated later to form a complete software. Each unit is developed independently and can be tested for its functions. This is called unit testing. uh, it simplify it simply verifies if the current if the unit meets the specification or not. What does that mean is that whatever instruction we have written in the software development, whether that instruction will give the proper output or not. So if it gives proper output, it means testing is positive. If there is some fault in the instruction, it means there is some error in the testing during testing, and we improve that instruction so that it will give the correct answer. So each and every instruction is independent on of itself, it does not depend upon other, so we call it as unit. This involves functional test at the interface of the modules, but also more detailed tests which consider the inner structure of the software module. So once the units are you can start writing, you are generated, you start making the modules, or you can say functions, or you can say components. And once the function modular components are generated, then you start integrating all the module functions or components together, so that while interaction with either each other, you can see they can share the data, collect the data, and make whole the software work properly. So during integration, the unit which are developed and tested for their functionalities are brought together. So integration means they are brought together to share the data. And the modules are integrated into complete system and test to check if all modules cooperate as expected. If one module call another module that take my input and give me some output, does the second module accepting the input and providing the output or not? So if all these activities are being performed easily, it means there's no error in the interaction among the modules. If one module is accepting the input but not giving the output, it means something is wrong over there. So we have to check what wrong is over there, what is problem over there, and improve that problem over there. This is, we call it as integration of the component or modules. And in this phase, you integrate all the modules in the system and test them as a single system for all the use cases, making sure that the module meet requirements. So once you integrate all the modules, then you check that where as per the user requirement, does the system or software providing the proper result or not as per the requirement of the customer or end user. After successful integration, including the related tests, the complete system has to be tested again the initial requirements again. The complete test will include the original hardware and environment, whereas the previous integration and testing phases still be performed in different environment or on the uh, test bench. Earlier testing is being done at the software developer end, which has its own, you can say, platform and hardware requirements. But the customer who has given the order has some different platform and hardware requirements its own end. So testing is again done in the virtual, platform, or you can say uh, uh, arrangement of the customer, that whatever the platform the customer is having, same platform will be provided over there. What are the hardware requirements are there in the customer, and same hardware requirement will be brought into the organization, and we'll check whether the software will run under that platform or not. So if it will run, then this is good. If it is not giving the proper output, it means some error is there, if it's not running as per the requirement of the user. So this is what the coding is. So under the testing, the various test cases are being performed. So we'll discuss the various test cases one by one. Next is the testing. In testing, the various test cases are being designed. Under test cases, we generate some few cases, and as per the cases, we give the input, and we verify, we check that whether the proper output are being given by the software or not. So this is being done in the case of the test cases under testing. For testing to be successful, proper selection of test cases is essential. The approaches for test cases are functional testing and structural testing. Under functional testing, we have module to be tested and treated as black box. Black box means that you give the input and check the output. If the output is as per the input and giving the proper result, it means the black box testing is successful. And if you are getting the wrong output as per the input, it means something is wrong in the system. So you will ask the software engineer that I'm not getting the correct output as per the input. So as per my blackboard testing, so it means something is wrong in your end. So kindly improve it. So the test cases can be based on the requirement of the system or modules. So the testing is the black box testing. So focus on external behavior of the system. So black box means you are unaware of what instructions are being used, how many modules are being used to develop the system. So you will ask the software engineer that I have tested your software, and I give the input to it, and I try to get some output from it, and when it generates some output, that output is or are not as per my requirement. So kindly check it, and kindly debug it and improve the outputs as per my requirements. So these are the test cases that are being performed to check whether the software is giving the proper results or not. And this is how the testing can be done. After testing, the last is the maintenance. So the software is handed over to the customer and will be used first uh, time by the customer, him or her. The customer will check if his or her requirements were implemented as expected, but he will not validate if the correct requirement have been set up in the beginning. In case there are exchange, if there are changes necessary, it will be fixed to make the software usable or to make it comply or fulfill the customer wishes. The most of the waterfall model description, this phase is extended to a never-ending phase of operation and maintenance, because every customer keep on changing his or her requirements and keep on adding some new operation in the software as per the technology and as per the uh, needs by the market. And all the problem which need not arise during the previous phases will be solved in the last phase of the software development. So this is all about the various phases of the software development, in which we have discussed what is feasibility study, analysis, design, coding, testing, design, implementation, and maintenance. So what are the advantages of the waterfall model? It is simple and easy to understand and use. As you can see, uh, the first phase is the feasibility study, second is the requirement analysis, third is the design, then coding, then you can say testing and maintenance. So one by one, each activity is being performed by the in various phases. easy to manage due to the inflexibility of the model. So they are not regular changes in the model, so it is very easy to design the make the activities in phases. Each phase has specific deliver and review process. Phases are processed and completed one at a time. So you can see at one time one phase is being completed, and after the positive result of the one phase, it is shifted to the next phase. Works well of small projects, where requirements are very well understood. So usually the waterfall model is successful where the you can say the projects are of size small size, and in which the requirements are easily understood by the software engineer. Clearly define the stages. So here we define all the stages, what activities are performed in each stage. Well understood milestones. So the software engineer have very easily understood that what, or you can say set up the various milestones, that how I can design software by putting on the milestones. Easy to arrange the task, and finally process and result are well documented. You can see that in every phase, the software engineer designed the document so that you can easily understand what activities are being performed in each of the phase. And some of the disadvantages of the waterfall model are: no working software is produced until the late during the life cycle. High amount of risk and uncertainty, because we have decided that last interaction with your customer is, let's say, 4 months back, and within the period of this 4 month many things are being changed in the market. So it may be possible that your customer say, no, I don't want my project, thank you very much for doing all these things, and it's totally wastage of your time. It might be risk and uncertainty. So not a good model for complex and object oriented projects. So as you say, as you said in the last advantages, that is usually waterfall model is useful for the small projects, but not good for the complex or big projects. A poor model for long and ongoing projects. So it's not a good model for the projects that are for a long time. Not suitable for projects where requirements are at moderate or higher risk of changing. So here you can see in the waterfall model, the requirements are being done at only one interaction with the customer. So usually the requirements of customer keep on changing as per the change in technology. So if you are not interacting with your customer regularly, it means your software you will develop will not be feasible in the market. Fine. It is difficult to measure the progress within the stages and cannot accommodate changing requirements. I told you earlier, because requirements is only in one phase, you're not interacting again with your customer for requirement. It means cannot accommodate the changing requirements of the customer. So these are some of the disadvantages why the waterfall model is not good for, or risky for the big projects in which the requirements of the customer keep on changing regularly. So this is all about the waterfall model that we have discussed so far. That how we have discussed that how all these phases interact with each other. How one phase is started and completed and give push to the next phase. The next phase started and completed, give push to the next phase. So on, keep on going until the last phase. And you will see that how all these things happen in detail in each and every phase, and you have learned advantages and disadvantages of the waterfall model. So this is how we can see the working of waterfall model is, and I hope you understand the working of the waterfall model and understand the various phases of the waterfall model, and you understand how the all phases work together, and what is the pattern of the various phases, which one is the first, which one is the last, and what are the various activities are being performed in each and every phase of the waterfall model. So I hope you enjoy the today's lecture. Uh, Thank you.